Hi guys, welcome back to Foundation Chemistry YouTube channel. So today we will talk about proposed mechanism of a reaction. So that means how to write the mechanism of a reaction. So usually 11th and 12th standard student they write the reaction products and its reagents. And some of them might be curious to know how the reactant is converted to product. So for that process you need to know the mechanism. So we all know what is a reaction. So usually the reactants react with the reagent to give rise to the product. And the reactant is usually written on the left hand side and the product is written on the right hand side. And the reagents are written on the arrow mark, or you call it reaction arrow. Then it will be interesting to know what is a mechanism. So mechanism is the movement of a double-headed arrow or single-headed arrow. Okay, so that in which way the bonds are broken and the new bonds are formed, leading to formation of product from reactant with the help of reagents, which may be a multi-step process or one-step process. So it is interesting to know what are the symbols used in writing the mechanism of a reaction. So this one, first one, the reaction arrow. It is used to show that the reaction is taking place in forward direction. This one, the curved double-headed arrow. So which means it shows that on which direction the bond is breaking, and it also shows that the motion or movement of two electrons. Similarly, this one, the curved arrow, single-headed arrow, or you can call it fish-hooked arrow. So which means the movement of one electron only that lead to free radicals. Similarly, this one is known as delocalization arrow. So this is used to write the delocalized or resonance stabilized structures. And the last one, equilibrium arrow, which means the two structures are interconverting with each other. So this is the simple reaction where reactant AX is reacting with some reagent to give rise to the product By. And the reactant always contains some bonds. And in chemistry we have different types of bonds, but here we will concentrate on ionic and covalent bond. So when the reactant AX contain ionic bond, so they simply exist as ions, A plus X minus, or it will be A minus X plus. Similarly, if the reactant contain covalent bond, so what is a covalent bond? The covalent bond is formed due to the sharing of one electron from each atom. So here you can see it is shared by both the atoms that lead to the covalent bond. And again we represent that bond as a line. So a hyphen, or you can go to single line X. And generally the covalent bond is of two types, polar covalent bond and non-polar covalent bond. When the electronegativity value of A and X are different, then that lead to polar covalent bond. And when the electronegativity value A and X are same, that lead to non-polar covalent bond. So here the curved arrow, two-headed curved arrow, so it shows the direction on which the bond is breaking, and again it also shows the motion of two electrons. So that means if the bond is breaking on atom X, so that will get two electrons, so it will give rise to X minus with two electron, and atom A will be electron deficient with no electron, so it will be A plus. So A plus is called electrophile and X minus is called nucleophile. Similarly, it can happen that this X bond can break on atom A, so that lead to A minus and X plus. So in general, what is a nucleophile? Who can attack? So the nucleophiles can be negatively charged species with a pair of electron, or it can be neutral species like water or ammonia containing lone pair of electron, or it can be electron rich species like double bonds or triple bonds. And generally electrophiles are electron deficient species, and usually it is positively charged. So in general, we can write nucleophile as Nu minus containing a lone pair of electron and electrophile as E plus. So it is very important to know that the nucleophile is electronically rich because it contains 2 electrons. So the nucleophile will attack to the electrophile always. So the lone pair of a nucleophile always attack to the electrophile which is electronically deficient, giving rise to nucleophile electrophile bond. So here you can see A minus nucleophile, X plus electrophile. So you get AX bond. So here I have shown that E plus is also, if somebody will write E plus will attack Nu minus nucleophile. So that is totally wrong. You should never write. So this process does not happen. So now if we take one example. So Rx, the reactant will react with the reagent sodium hydroxide to give rise to product ROH alcohol plus NaX. So this is the proposed reaction mechanism. So NaOH ionic compound we know, so that give rise to Na plus ion and OH minus ion with a pair of electron. So during multi-step reaction mechanism, it will consist of different elementary steps. So in first step Rx, so that Rx bond will break on atom X because its electronegativity value is higher. Because whose electronegativity is higher, so the shared pair of electron will be more attracted towards itself. So that is the concept of electronegativity. So that lead to R plus and X minus. And in the reaction medium we have OH minus ion. So OH minus ion will attack the electrophile R plus, giving rise to ROH, the product. And Na plus and X minus, they will combine to give NaX. And in single step reaction mechanism, so both bond making and bond breaking is simultaneous or concerted process. So here the lone pair of electron of OH minus ion will attack R and this Rx bond will break on atom X, giving rise to ROH plus X minus with a pair of electron. Similarly, another process happens when the homolytic bond cleavage takes place. So this is represented by a single headed arrow or fish-hooked arrow. So where the bond cleavage takes place and each atom gets 1 electron each. So A dot and X dot, these are called free radicals. And during radical recombination process, when I write the mechanism for product formation, so A dot, X dot can recombine giving rise to AX. Similarly, A dot or X dot can recombine to give rise to A2 and X2 as product. So there is one assignment for you guys. So when cyclohexane will react with the reagent chlorine in presence of light, so what would be the product? And please write down a plausible mechanism by using free radical concept, because I have given the hint light. So please join our channel, and I will be happy if you subscribe and click the like button. So this is a simple step towards e-learning, making life better. So thank you all for watching.